కిందికి పెట్టాము నిన్న రోజు జనరల్ Good morning, students. In the last class, we have discussed about that fructose structural elucidation. In that fructose structural elucidation, the formula of fructose is same as it is. What about the glucose formula is equal to fructose formula? That one is C6H12O6. Then is C6H12O6. It is also belongs to fructose formula. The difference of glucose and fructose is that one is only functional group difference is there. In the fructose, we will having keto functional group is present, whereas glucose are having aldehyde functional group is present. The fructose is also in the last class we have discussed 5 hydroxyl groups are present. The 5 hydroxyl group based on the acetic anhydride we can identify the reaction. That is fructose pentaestate will be formed. And after that, that fructose material reacts with hydrogen cyanide. It will be formed cyanohydrin and hydroxylamine. It will form oxime. Based on this reaction, what we are confirmed in the fructose, carbonyl group is present, and identification for failing test and as well as tolerance test is there. Based on failing test, tolerance test, the keto group is confirmed. Next, same as it is reaction with hydrogenated phosphorus red, it will be having open chain structure, it will be takes place. So, the fructose will also having what type of ring means 5-membered ring it will be formed. That is fructopyranose ring it will be formed. How it will be means carefully observed. CH2OH, Now here C double bond oxygen, then CH2OH, first carbon, second, third, fourth and fifth carbon, this one is sixth. This one is third carbon and this one is fourth one, fifth one and sixth. The third carbon OH group towards your left side, like this is the arrangement is there. Carefully observe, in the fructose is also does not react with sodium bisulfite and ammonia because of its a cyclic structure it will be takes place. The cyclic structure is Furanose ring. Carbon to oxygen, which electronegativity is more oxygen. These bond electrons are attracted to oxygen. Here oxygen get negative charge, whereas carbon gets here positive charge. Here the fifth carbon OH group is present. Oxygen and hydrogen, oxygen electronegativity is more and it will be having minus, and this hydrogen having plus charge. This hydrogen plus is bonded in the area of oxygen, that oxygen minus is bonded in the area of carbon. So this one is carbon. Here CH2OH, this one is first carbon, CH2OH, and here OH group is there. These two electrons are attracted to oxygen minus and this hydrogen is bonded OH, and this one is the carbon chain. Now CH2OH, first carbon, second, third, fourth, fifth, and this one is sixth carbon, it will be there. CH2OH, 1, 2, 3, 4, 5, 6. Here OH group, hydrogen, OH, hydrogen, and here it will be ring formation is takes place in between second carbon and fifth carbon. The ring formation in between second. See that carefully. 1, 2, 3, 4 and 5. How many number of atoms are present in the ring? In the ring we will having the 5 member atoms are there. So that is the reason the structure is Furanose structure. The first carbon, that OH group is present towards ring side, that is alpha fructo Furanose ring, and if the OH group present opposite to the ring side, that is beta fructo Furanose. This is alpha fructo Furanose ring. This is alpha fructo Furanose ring, and if you are writing like this, if this OH group present towards your left side, CH2OH, now here CH2OH group, third, fourth and fifth, here first carbon, second, third carbon, fourth, fifth one and sixth one, here OH group, H, OH and hydrogens, and here ring formation it will be takes place in between second carbon and fifth carbon. Opposite to ring structure, opposite OH group is there, that is beta fructo Furanose ring, it will be there. And this is Fischer representation according to, what about the pyranose representation? In every carbon, two groups are present here. First carbon, two groups. This one is, these are the carbon atoms. See that here CH2OH, first carbon, second carbon, third one, fourth one, fifth one. And here see ring side will have in the downward direction, here CH2OH, OH and H, OH, and here OH and H, and here hydrogen and CH2OH. This one is sixth carbon. Next this one is beta fructofuranose according to Haworth system, pyranose system like this. Here CH2OH, H, OH, next here hydrogen and OH group, here OH and hydrogen and CH2OH. This one is sixth carbon. First carbon, second one, third one, fourth one, fifth one, sixth. Carefully observe, ring side will have in the downward direction, ring side will having the downward direction, and in opposite side in the top direction it will be takes place. So that one is beta fructofuranose, that is the Haworth structure of the system. Carefully note down, according to second carbon and fifth carbon, ring formation is takes place. Note down speed. Next one, the carbohydrates, the best suitable test for Mollis test, alpha naphthol, beta naphthol compounds are identification. Violet color component is formed in the test for identification. In that biomolecule, another subtopic is amino acids. Here carefully observe the synthesis of different type of proteins. The amino acids are essential. In the body, different type of amino acids are present. That preparation of the amino acids, it form proteins. The proteins will have what type of bonds are present? Peptide bonds are there. These amino acids, based on the activity, different type of physical and chemical activities, biological function will be takes place. That amino acids are the major unit of amino acid means here R alkyl group, CH, NH2 and C double bond OH is present. Carefully observe, if any compound will having amine group and as well as acid group, amine group and acid group, both groups are present. So, the type of compounds are amino acid. These amino acids are will having the acidic nature is present, basic nature is present and neutral nature is also present. How we can see the acidic nature means here acid functional group is there. So, that is the reaction, acid reactions are takes place. And amine, nitrogen having lone pair of electrons are present. These lone pair of electrons are donating properties will be present. Due to the donation of the lone pair of electrons, that will be having the basic nature is also present. Amine group and acid group both are there. So, that is the reason neutral reactions also takes place. Based on that amino acid, if any compound will having amine group and acid groups are there. So, the type of compounds are amino acids. These amino acids will having the nature is acidic nature, basic nature and neutral nature it will be takes place. And based on the position of amine group, based on the position of amine group, based on the position of amine group, the amino acids are classified as alpha amino acids, beta amino acids, gamma amino acids, etc. Alpha amino acids are major toward the category in the amino acids, that is also called as natural amino acids. The majority of the amino acids are alpha amino acids, that is also called as natural amino acid. What went by one that the same condition means, if you take any compound, the compound will have in the acidic group and amine group both are present. The type of compounds are known as amino acid. The first classification based on the arrangement of the amine group at the position. So, here what are the groups are there? COOH groups. Here alkyl group CH, NH2 and C double bond OH is present. Acid group adjacent carbon, this is acid group. In the top priority according to the polyfunctional group order, if two or more number of functional groups are present, the decreasing order of the polyfunctional group orders are acids, acid derivatives, nitriles, aldehydes, ketones, alcohols, amines, ethers, alkenes, halogens and alkynes. So, based on that category according to your first year, the first priority goes to which one? Acids. And acid adjacent carbon means that is first carbon, this one is second carbon. Functional group adjacent carbon is also called alpha. So, this type of compounds are called alpha amino acids. And if you write like this, R, CH, NH2 and CH2, C double bond OH. See that this one is functional group adjacent carbon is alpha carbon adjacent carbon is beta. That is in the common name criteria. How we can represent functional group adjacent? Which one is the major functional group? Acid group. Functional group adjacent carbon is alpha adjacent is beta. So, this type of amino acids are called as beta amino acids, If you write like this, RCH, NH2, CH2, C double bond OH, this one is the functional group adjacent carbon is alpha adjacent is beta adjacent is gamma. So, this type of amino acids are called gamma amino acid. If you take any compound, the compounds are having amine group and acid groups are present, it is called amino acids. Based on the position of amino acid. The first classification is based on the position of amino acid. The based on the position of amine group, that one is, if alpha carbon amine group is there, alpha amino acid, beta carbon amine group is there, beta amino acid, gamma carbon amine group is there, gamma amino acid. So this type of classification is present. In the place of R, you may substitute any alkyl group, whatever it may be. If you are substituting different type of alkyl group, you are getting different type of amino acids. Total 25 amino acids are there. In that 25 amino acids, we will having the 2 are amino acids. Amine group, NH group is present. Amine group, NH2 group. Amine group means NH group is present, that is proline and hydroxyproline it will be there. So the natural amino acids are all are alpha amino acids. Now if you are changing the alkyl group, you are getting different type of amino acid, different type of amino acids. All amino acids are optically active. All amino acids are optically active except glycine. All amino acids are optically active except, what about the glycine? Glycine is optically inactive amino acid. Glycine is optically inactive. So all are having optically active. The only one amino acid, optically inactive amino acid is there. The example for optically inactive amino acid is glycine. Why optical activity means the carbon 4 valencies are satisfied with 4 different groups, that is called optically active. The carbon 4 valencies are not satisfied with the 4 different groups. If any 2 groups are same, automatically that compound is optically inactive. Optical active compound, either dextrorotator or levorotator, that we are discussed in the DL configuration earlier in the carbohydrates. And if you see that COOH, I am writing CH3, CH, NH2, COOH. This compound common name is alanine. This compound common name is alanine. Alanine is a natural amino acid. If you take here amine group is present, here acid group is there, here methyl group is present, and here hydrogen is there. The carbon 4 valencies are satisfied with 4 different groups. In the place of alkyl group, what I am doing, the base unit is, amino acid base unit is how we are representing RCH NH2 COOH. That is, we can C double bond OH, RCH NH2 COOH. In this R position, what I am doing here, I am substituting methyl group. If I am substituting methyl group, that compound is alanine. IUPAC name is 2-amino-propanoic acid. 2-amino-propanoic acid, common name is alanine. According to Fischer projection formula, if you write this compound is CH3 and here NH2 and hydrogen is present. Now this is the central atom carbon. The carbon 4 valencies are satisfied with 4 different groups. So that compound is optically active compound. If you are writing in the R position hydrogen, H, CH, C double bond OH, that is NH2. In the alkyl group position, if I am substituting hydrogen, that compound is called as glycine. That compound is known as glycine. See that carefully. In the position of alkyl group, if you are substituting different type of alkyl group, we are getting different amino acids. That is alanine, glycine, valine, proline, hydroxyproline, leucine, isoleucine, arginine, tryptophan. Like this different amino acids we are getting the alkyl group. Now, if I am substituting hydrogen here in the place of alkyl group, if I am substituting hydrogen, that one is glycine. This glycine is optically inactive. Why this optically inactive? Carefully observe. Here one amine group is there. Here acid group is present. And here how many hydrogens are there? 2 hydrogens are present. Observe here C double bond OH. And here the carbon and NH2 group. And these are the 2 hydrogens are present. In this compound, how many carbons are there? See here, 1, 2 carbons are there. Here one is acid group, this one is acid group. And this is the carbon, here one NH2 group is there, NH2 group. And these are the 2 hydrogens are present. So due to these 2 hydrogens, this compound is optically inactive. When it will be optically active, the carbon 4 valencies, are satisfied with 4 different groups, then only the compound is optically active. So alanine is optically active compound, but whereas glycine is also amino acid. Why it's amino acid? Amine group is present as well as acid group is there. Both amine group and acid groups are present. It's called amino acid. The all amino acid, only one amino acid is optically inactive, that is glycine. What is optical activity? Means carbon 4 valence is satisfied with 4 different groups, then the compound shows optical activity, or asymmetric compounds is also shows optical activity. Asymmetric compounds also shows optical activity. Now see that here this is the carbon, here acid group is present, here amine group is there. 2 different groups are there, but these 2 are same hydrogens are there. So that is the reason this compound is optically inactive. So the first classification in the amino acids are based on the position of amine group. If the amine group position will be changes, we are getting different type of amino acid, like that alpha amino acid, beta amino acid, gamma amino acid, delta amino acid, etc. These all alpha amino acids are combined together to form what about the proteins, and it is form also peptide bonds. And this different type of amino acids undergo the hydrolysis, we are getting different amino acid structures. Amino acids are combined together to form protein structure. That proteins, primary protein, secondary protein, that will be discussed. The first classification is based on the what about this position of amine group. Second classification based on the what about this human body activity. So the second classification is essential amino acids and non-essential amino acid. First classification based on the position. Second classification of amino acid based on the human activity or biological activity. Which amino acid is suitable for the what about the different type of biological functions? The type of amino acids are essential amino acid. So our body can be synthesized. Our body can be synthesized itself. Our body can be synthesized itself. తనంతట తానే తయారు చేసుకుంటాయి కొన్ని అమైనో యాసిడ్స్. ద టైప్ ఆఫ్ అమైనో యాసిడ్ వీ నీడ్ నాట్ టు టేక్ బై ద ఫుడ్. ఆల్రెడీ బాడీ తయారు చేసుకునే వాటిని మళ్ళీ ఫుడ్ రూపంలో తీసుకోవాల్సిన అవసరం లేదు. అట్లాంటి అమైనో యాసిడ్స్ని ఏమంటామంటే నాన్ ఎసెన్షియల్ అమైనో యాసిడ్. Carefully observe, another classification is to essential and non-essential amino acid. Essential and non-essential. Essential means compulsory we have to take the amino acid, means materials by whatever the vegetables or fruits or different type of food items we have to take for different type of biological functions. The type of amino acids are called essential amino acid. Essential means compulsory we have to take whatever the by external material, means that food material we have to take that, then only biological function will be takes place. The type of amino acids are called essential amino acids. Another amino acids are non-essential. Non-essential means we need not to take the food. అంటే మనం ఫుడ్ రూపంలో తీసుకోవాల్సిన అవసరం లేదు. We need not to take the food materials for the development of the amino acids. So already our body can be, మరి వాటికి ఎట్లా వస్తాయి, body can be synthesized for different type of what about the chemical reaction, body can be synthesized some amino acids. The type of amino acids called non-essential amino acids. So essential amino acids and non-essential. Essential means by taking the food, that is essential, and if you are need not necessary to take by the food, the type of materials are called as non-essential amino acids. Non-essential amino acid materials. And another one is based on the what about the arrangement of the functional groups and nature. The functional group nature, another classification is based on the functional group nature. According to the functional group nature, the relative number of NH2 groups and CH2 and nature. The first one is the amino acids are here, the basic unit is R, CH, NH2 and C double bond OH is present. R, CH, NH2, COOH is present. In this first classification is position of amino acid. Second classification is essential and non-essential condition. Third classification is based on the nature. Nature means here one amine group is there, one acid group. Amine group means what type of character it will be? Base character it will be there. How it's called as base? The base means nitrogen having lone pair of electrons are there, and those lone pair of electrons are donating properties present. It's called as base. This one is acid. In this acid, if H plus ion is what about the released, it's called acid. So only one amine group, one acid group is present. This type of amino acid is called neutral amino acid. If number of acid groups are more, that is called acidic amino acid. Number of NH2 groups are more, that is known as basic amino acids. Again, based on the nature, the classification of amino acids are 3 types: neutral amino acids, acidic amino acids, basic amino acid. Neutral amino acid means it will be having one amine group and one acid group is present. So, neutral amino acid means what? Here neutral amino acid means one acid group is present and as well as one amine group is there. One acid group, one amine group, both are present in the system, it is called neutral amino acid. Acidic amino acid means two acid groups and one base group is present. Two acid groups means acidic groups are more, that is acidic amino acid. Basic amino acid means here one acidic group and here two amine groups or two or more than amine groups are present, that is called basic. If number of amine groups are more, that is known as basic nature. Number of acid groups are more, it is called acidic nature. Both one acid group, one amine group is present, it is called neutral. Based on the nature, carefully observe here. This one is amine group and acid group. Neutral amino acid means one acid group, one amine group is present. Acidic amino acid means more number of acid groups, or that is two acidic groups or only one basic group, or two or more number of acidic groups is also present. The type of amino acid is acidic. Basic means acidic groups are less and amine groups are more. Basic nature means amine groups are more and acidic groups are less. The type of amino acids are basic amino acid. Now I will write one example here for simplified example, that is alanine. What is the formula of alanine? CH3 CH NH2 COOH. CH3 CH NH2 COOH. This one is alanine. This one is alanine and glycine CH2 COOH and this one is NH2 is present. Now carefully observe. This one is alanine and this one is glycine. This one is glycine. In these two amino acid belongs to, in these three which category it belongs to? Here I am represented two example, one is alanine, another one is glycine. These two examples are belongs to which type of amino acid, either neutral or acidic or basic. Which type of amino? Exactly, that one is belongs to neutral amino acid. Why it's called neutral amino acid? In the neutral amino acid, one acid group is present, one amine group is present. In the neutral amino acid, one acid group and amine group. See that one acid group is there, here one amine group is present, here also one acid group and one amine group. If any compound will having acid group and amine groups are present, the type of compounds are called as neutral amino acids. Next one is acidic amino acids. In that acidic amino acid, here acidic groups are more, that is called as aspartic acid. In that aspartic acid, will having how many acidic groups are present means two acidic groups are there and one basic group is present. See here another example for acidic amino acid. In this acidic amino acid, one the best example is aspartic acid. Here CH COOH CH NH2 and here acidic group is present and what about the amine group is there, and another one is CH2 and here C double bond OH group is present. CH2 C double bond OH group is present. And carefully observe, in this amino acid how many acidic groups are present means here two acidic groups are there. When two acidic groups, only one amine group is present, that nature is belongs to acidic amino acid. Acidic amino acid. Another one is glutamic acid. Another one is glutamic acid. I think you know very well in that nomenclature of organic compounds is the dicarboxylic acid is there. In the dicarboxylic acids, oxalic acid, malonic acid, succinic acid, glutamic acid, adipic acid is there. Oxalic means 2 carbons, malonic acid 3, succinic acid 4, glutamic acid means 5. So see that 1, 2, 3, 4, 5. This is glutaric acid, glutamic acid, glutamic means NH2 group is present. So glutamic acid is there. Now this one is aspartic acid. Here this one is aspartic acid. Aspartic acid belongs to what type of amino acid? Aspartic acid belongs to acidic amino acid. Why it's acidic amino acid? See carefully observe, in this amino acid, 2 acid groups are there, here more number of acid groups are present, one amine group is there. So that is the reason aspartic acid belongs to what type of amino acid means acidic amino acid. Glutamic acid is also belongs to acidic amino acid, glutamic acid. In this, one amine group is present. Here how many acid groups are there? 2 acid groups are present. So, that is belongs to glutamic. Glutamic acid is also example for acidic amino acid. If more number of acidic groups are there, that character is acidic nature. More number of basic groups are present, that character is also basic nature. Base means amine groups are more. Amine means NH2 groups are more. How NH2 group act as a base? According to acid base theory, 3 theories are there. Arrhenius theory, Bronsted-Lowry theory, Lewis acid base theory. Arrhenius theory means proton donor is acid, that is H plus ion donor is acid, OH minus ion donor is base, that is Arrhenius theory. According to Arrhenius theory, H plus ion is donation material is called acid, OH minus ion donating material is base, that is Arrhenius. Bronsted-Lowry theory means proton donor is acid, proton acceptor is base. Proton means H plus ion, H plus ion donor is acid, H plus ion acceptor is base, that is Bronsted-Lowry theory. Next, Lewis acid base theory. According to Lewis acid base theory, electron deficient compound is acid, electron excess compound is base, or electron acceptor is acid, or electron donor is base. Here in the amine group, nitrogen having lone pair of electrons are there. This lone pair of electron nature is donating property is present. So, that is the reason according to Lewis acid base theory, amine group act as basic nature. Amine group act as basic. Now, see that here glutamic acid, 2 acid groups are present, 1 amine group is there. In that basic amino acid means 2 amine groups and 1 acidic group is present. The type of amino acids are called as basic amino acid. The basic amino acid, the best examples are arginine and lysine material. Here, if you see that arginine structure, CH, NH2, COOH. CHNH2, COOH, then CH2, 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 NH, C double bond, NH, and if you see this, the compound, and if you see the compound here, acid group is present, NH2, how many CH2 groups are taken are NH2, right. Now, here how many amine groups are present here? The total number of amine groups are, 3 amine groups are here, 1 NH2 group is there, here also this one is imine group, this group is imine group. Number of base units are more, and here only 1 acid group is present. Number of amine groups are more. That is, what about the basic amino acid? So, acidic amino acid means acidic groups are more. Basic amino acids means basic, what about the NH2 groups are more. Next, another one is lysine. This one is arginine. Another one is lysine, CH, COOH, and here NH2 group, CH2, 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 CH2. See that here how many carbons are there here? In the earlier 3 carbons are there. Now, here total 4 carbons are present, and also having, what about this here, NH2 group is present. This nitrogen having lone pair of electrons are there. Now, in this compound 1 acid group is present, and how many amine groups are there means 2 amine groups are there. 1 acid groups, 2 amine groups are present. The type of nature of amino acids are called basic amino acid. Base means, what about the number of electrons are donating property is called base, and H plus ion donating property is called as acid. Arginine, and this one is lysine. This compound is arginine, this compound is lysine. So, number of amine groups are more, nature is basic. First classification, again the amino acid classification is first one. What is the first classification? Based on the position of functional group. If the position of functional group, that is amine group position is alpha, beta, gamma, delta, it will be takes place. See that carefully. This one is C double bond OH group, and this one is the carbon chain is present. In this carbon chain, functional group adjacent carbon is alpha, alpha adjacent is beta, beta adjacent is gamma, gamma adjacent delta, delta adjacent is omega, epsilon, eta, theta, like this. But this much is enough. See that how we can represent alpha, beta, gamma means this one is functional group. That functional group adjacent carbon is alpha. Functional group adjacent carbon is alpha. Alpha adjacent carbon is beta. Beta adjacent carbon is gamma. Gamma adjacent is delta. Delta adjacent is omega. Like this alpha, beta, gamma. This is first classification. Based on that thing, the position of amine group is alpha position, alpha amino acid, beta position, beta, gamma position, gamma, delta position, and omega position. That is first classification. Second classification, based on the nature, essential, non-essential. Body can be synthesized, that is what about the need not take by the food, that is non-essential. Compulsory we have to take by the food materials, the type of amino acids are essential. After that, based on the nature, that amino acids are three types of natures are there: neutral amino acids, acidic amino acids, basic amino acid. Neutral means one amine group, one acid group is present, neutral. Acidic means two acid groups, one base group is present. Basic amino acid means more number of amine groups and less number of acidic groups are present, that is called basic amino acids. And another one is sulfur containing amino acids are there. Another amino acid classification is sulfur containing amino acid, that is based on the source. One is based on the number of functional groups. Another one is based on the sulfur containing amino acid. If you are carefully observing that sulfur containing amino acids are best example for cysteine and dicysteine material. Cysteine and dicysteine materials. Sulfur containing amino acids. In that sulfur containing amino acids, here cysteine, the base unit is CH, COOH, and CH, here NH2 group is there, and this one is CH2 and SH group. Sulfur containing amino acid, this compound name is cysteine. This is one of the amino acid according to sulfur containing amino acid. Sulfur containing amino acid. Next, another one, if two cysteine units are combining together, that is called as dicysteine compound, that is known as dicysteine compound. If you are see that CH NH2 COOH, CH NH2 COOH, here CH2 group is present and here sulfur group is there, and removal of this hydrogen, again I am adding sulfur. You can write again sulfur, here CH2, here CH NH2 C double bond OH. Up to this part is cysteine and this one is another cysteine. These two cysteine units are combining together, that is known as dicysteine. These are the sulfur containing amino acids. Another example is also sulfur containing amino acid is there, that is methionine. That one is methionine. Here base unit is CH NH2 COOH, this one is base unit CH2 and CH2 SCH3. That is what about this sulfur containing another amino acid, that is also called methionine material. This is also called methionine. Here sulfur group is present in the chain. Carefully observe here, this in every time this one is base unit, it will not be changed. This one is base unit. In that base unit, after that area, this part is called as alkyl part. That alkyl part is changes. See that this one is base unit, CHNH2CO. This entire part is alkyl group. If changing the alkyl group, we are getting different type of amino acid, and this one is methionine. Methionine is also what about the essential amino acid. Essential amino acids. Essential means compulsory, we have to take by the food materials. It is called as essential amino acids. Next one, here sulfur containing amino acids, carefully observe what is that. One is cysteine, another one is dicysteine, and another one is methionine compounds. And another classification is also there, that another classification is aromatic amino acids. Aromatic amino acid means based on the aromatic ring. Aromatic amino acids. Aromatic amino acid, the best example is phenylalanine. That is phenylalanine. You know very well, alanine means CH3, CHNH2, COOH. In this condition, what I am doing here, in the CH3 part, this is alanine. What I am doing, phenylalanine. Phenyl means if I am removing this hydrogen, if I am adding aromatic ring means phenyl ring, that is benzene ring if you are added, it is called phenylalanine. Now phenyl group means is also C6H5. Now this is C6H6 is benzene. If you are removal of one hydrogen, because of every carbon one hydrogen is present, these all the 6 carbons and 6 hydrogen is there, and removal of one hydrogen in the benzene ring, that group is phenyl ring. And here CH2, removal of this hydrogen CH2, and again CHNH2 COOH. Now this one is alanine and this is called phenylalanine. This is known as phenylalanine. Phenylalanine. This type of amino acids are called aromatic amino acid. You know very well in the first year, aromatic compound means the compound which are obey the Huckel's rule. The compound which are obey the Huckel's rule, those compounds are called aromatic compounds. If any compound obey the Huckel's rule, it is called aromatic amino acids. Another one is tyrosine. The tyrosine is also belongs to aromatic amino acid. Here phenyl ring, CH2, CHNH2, COOH. In the para position, in this para position, if OH groups are present, that is called tyrosine. Tyrosine is also belongs to aromatic amino acid. Tyrosine is also aromatic amino acid. Next another one is thyroxine, that is also called iodogargine. Thyroxine also called iodogargine. Here see that CHNH2 COOH, CHNH2 COOH, this one is base unit. According to the base unit, if you are writing that phenyl rings here, CH2, phenyl ring, and here oxygen, again phenyl ring, and remaining materials are substituted by the 4 iodines. Remaining materials are substituted by the 4 iodines at the meta position of the groups. Here that OH group is present, and here also one iodine is there. Also iodine, and iodine. This compound is thyroxine. This is also called iodogargine. Once again, these are the amino acids are belongs to what type of amino acids? Aromatic. Aliphatic amino acids and aromatic. Aliphatic means open chain compounds, and that open chain compounds essential, non-essential, natural, acidic, basic natures are there, and also sulfur containing amino acids are present. The next one is aromatic amino acid. Aromaticity means if any compound obey the Huckel's rule. I think you know very well of the Huckel's rule. Huckel's rule means 4n plus 2 number of pi electrons are present, cyclic structure is there, and those pi electrons are arranged in the conjugation manner. When it will be having conjugation manner, it will having sp2 hybridization. When sp2 hybridization is there, planar geometry it will be takes place, delocalization is takes place and shows the resonating structure. The type of compounds are called Huckel's compound. According to Huckel's rule, if any compound shows the Huckel activity, that compound is aromatic ring. Based on the aromatic nature, the amino acids are again aromatic amino acid, means here aromatic ring is present. The best example is every time the base unit will be same, CHNH2 COOH, in the place we can add this group. Now phenylalanine, and in the para position, same structure in the para position, if you are added OH group, thyroxine, and this one is iodogargine, and iodogargine, this one is tyrosine, and this one is iodogargin, that is thyroxine material it will be takes place. This is what about the classification. Next, heterocyclic amino acids. Next classification is heterocyclic amino acids. Aromatic amino acids, heterocyclic amino acid. In the name is also there hetero. Hetero means two or more number of groups are different, that is heterocyclic amino acid. In that heterocyclic amino acid, non-aromatic heterocyclic amino acids, aromatic heterocyclic amino acid, homocyclic and heterocyclic. If in this is the carbon chain, this is homocyclic, all are having carbon atoms. If all are having carbon atoms, that is homocyclic, and we will having the alternate double bonds are there, that is aromatic ring, homocyclic. Hetero means in the carbon chain, in the carbon ring, if any heteroatom, either nitrogen or oxygen or what about the sulfurs are present, the type of natures are called heterocyclic. Hetero means, carefully observe, in the ring heteroatom is present, other than carbon atom is heteroatom. Other than carbon atom is heteroatom. That generally heteroatoms are either nitrogens or oxygens or sulfurs are present. Along with the ring, in the ring only, if heteroatom is present, that is what are the heteroatoms, nitrogen, oxygen or sulfur. If alternate double bonds are there, that is aromatic heterocyclic. Now what I am doing, non-aromatic heterocyclic amino acid. Non-aromatic heterocyclic amino acids are, the best examples are proline and hydroxyproline. Proline, that is here this is NH group, and here COOH group is present. This compound is proline. This compound is proline, and another one is hydroxyproline. Non-aromatic heterocyclic, this is heterocyclic. Why it is treated as heterocyclic means, in the ring the heteroatom nitrogen is present, the heteroatom nitrogen is present, that is non-aromatic heterocyclic amino acid. The best examples are proline and hydroxyproline. These proline and hydroxyprolines are non-aromatic nature, and this one is imine group is present. Carefully observe, NH2 group is called amine group. NH2 group is called amine group, whereas here what type of group is present here? NH group is there. So due to this NH group, these are called as imine groups, and these are imine. These are imine groups are there, not amine. Here imine groups are present. In that non-aromatic heterocyclic amino acid, the best examples are proline and hydroxyproline. Next, another one is aromatic heterocyclic amino acid. In that aromatic heterocyclic amino acid, tryptophan is the best example. This one is non-aromatic. And aromatic heterocyclic amino acid, here this one is phenyl group, and here NH group is there, and CH2, CH, NH2, COOH. See that here that one is aromatic heterocyclic group is present. This aromatic heterocyclic group is also the best example for tryptophan. This one is tryptophan. In the egg it will be there, that is tryptophan material. And histidine is also example for this compound, histidine material. The histidine is also example for non-aromatic heterocyclic. Why it is called as aromatic heterocyclic amino acid? This is aromatic ring, 4n plus 2 number of pi electrons are present. If you see that here double bond, here alternate double bonds are there. Aromatic ring it will be takes place. Due to this nature, this compound is what about the heterocyclic? Why heterocyclic? In the ring formation, other than carbon atom is there, so that is the reason it is heterocyclic, and it shows aromatic activity and amino acid group is there. So that is called as classification of amino acids according to the system. Now carefully observe, the classification is how many types of classification is present. In the first classification is will having based on the amine group. The first classification is based on the amine group, that is called position of amine group. Second classification is based on the what about the biological activity, that is essential nature, non-essential nature. And third category based on the amine group and acid group, that is called, if two amine, one amine and one acid is there, neutral and acidic and basic nature. And after that sulfur containing amino acid. These four categories are belongs to aliphatic nature. Aliphatic means open chain nature is there. This is one classification. Second one is aromatic amino acids. and after that heterocyclic amino acids. In that heterocyclic amino acid again two types, non-aromatic heterocyclic amino acids and aromatic heterocyclic amino acid. These are the classification of amino acids. These all amino acids are what type of nature is present? The all amino acids are, the nature is, what about this nature? Optical active nature is present. The only one amino acid will having that optically inactive amino acid is present. That optically inactive amino acid is glycine. So carefully observe that one question will be there in that glycine is optically inactive. The all amino acids are alpha amino acids, that is natural amino acids are takes place. Tomorrow we will discuss preparation of amino acids and these characters we will discuss in the tomorrow. So in that biomolecule, the first part is carbohydrate, the second part is amino acids. Thank you.